Today we're going to look at limit laws. This is in section 2.3 of the textbook. Please download the limit laws PDF on Canvas, and I will reference that throughout this. So when I say this is limit law number 6, it's just numbered 6 on that sheet. Okay, first one. So this one, the first 3 examples just build. So this first one, limit as x goes to 2 of x cubed. This is the first thing we do is plug in the value, so this would just be 8. So that's not an application. Well, it is an application of the limit law, but we've already talked about that one. Okay, and that's, so next. The limit as x goes to 2 of this cubic function. So this is rule number 1 on the limit laws sheet. So it's, in words, it's the limit of a sum is equal to the sum of its limits. So we can do this. We can take this limit and apply it to each of these independently. I'll be honest, this is not the fastest way to compute this limit. These problems are just used as a demonstration as to how to apply the limit laws. So the first one would just be 8. We already calculated that in the first example. The second one would be 10, because you can just plug in 2, so 5 times 2 is 10. And this third one is going to be an application of limit law number 7 on that PDF. So this one in words is the limit of a constant function is equal to the constant. And then we just sum those. So this would just be 25. So we're going to use that same cubic because we already have all the values for it. And this one is going to play with limit law number 11 on the PDF. So what you can do with this is bring that limit inside of the function and apply it to each piece separately. Okay, so now that's going to be the square root of 8 plus 10 plus 7, which is 25. Take the square root and you get 5. Okay, so let's go to the next one. Basic limit laws apply only when the limits of f of x and g of x exist. So when you do this, if one part of the limit doesn't exist, then the overall limit wouldn't exist. So in order to use the limit laws, all of the limits must exist for the whole limit to exist. So it's easier to look at an example like that. So for the first one, we have the limit of f of x times g of x if f of x is equal to x and g of x is equal to x to the negative 1. So without getting, writing out too much here, we know that f of x is x. So if I simply did something like this, well, normally f of x, this would be 0 because x is the function, and 0 times anything, it is going to be 0 normally. But if you look at this function, g of x, another way to write that is 1 over x. And that function isn't defined at 0. So this limit can't be found like this. So this would be does not exist. Because both of those limits have to exist, but in this case right here, limit is x goes to 0 of g of x. Well, you can't plug a 0 into g of x. So it doesn't matter that it's multiplied by 0. If one part doesn't exist, the whole thing doesn't exist. So your solution is just does not exist. Okay, in this example, this is going to be an application of limit law number 3 from the PDF. And what you can do with this is if you have a constant out front, so this is a 4, you can take that outside of the limit. So you could rewrite this as 4 times the limit as x goes to 2 of x squared. And then you can plug in that 2. So this would be 4 times 2 squared, which would be 4, or 16. So again, that's limit law number 3. The next example, the limit as x goes to 3 of x cubed. This would be an application of limit law number 6 from the PDF. So one way to do this is, or another way to write it might be the limit as x goes to 3 of x, and bring that cube outside. So in that case, we would just have a value of 3 inside and then cubed, so 3 times 3 times 3, or 27. So in this last example, we're going to apply the limit laws, mostly symbolically. And this has a very distinct AP feel to it. There are a lot of questions we'll do that have the same setup, and you'll get really familiar with these types of questions. Usually they're not a lot of work and they're more like puzzles. One of the things we can do, we're gonna use these limit laws. And so what we can do first is bring this limit inside of the radical. So I'm gonna bring it inside, and then what I'm gonna do, in one step, I'm going to apply it to each of those things separately. So the limit as x goes to 3 of f of x times the limit as x goes to 3 of h of x minus the limit as x goes to 3 of x squared times the limit as x goes to 3 of g of x. So I know it looks messy, but all we're doing is plugging in the defined values from above. So I'll have this square root. And then inside of the radical, the first one, the limit is x goes to 3 of f of x. Well, it's defined right up here as 2. So this is really just 2. The limit as x goes to 3 of h of x, well, that's defined right here. So that's just 3. Minus, well, we have this, circle this, you know what I'm talking about? This part right here, that's the limit as x goes to 3 of x squared. So that one's not defined above, but they don't have to be defined to be able to work with those. So we're just going to do that by plugging in that value. And so that would be the limit as x goes to 3 of x squared is 9. And then finally, our value of g of x. So that is defined, the limit as x goes to 3 of g of x is equal to -1. So even though this looked really messy, we're coming down to this pretty simple calculation here. So this would just be 6 square root of 6 plus 10, which is 16, and the square root of 16 is 4.